Hi Year 12 Maths General students. This is a little topic test with 10 questions on bivariate and time series data analysis for the Queensland General Maths syllabus, Unit 3. There's 10 questions, simple familiar, and a complex familiar, and a complex unfamiliar. And I've put them together based on questions that we've seen QCAA release in their external exam sample papers and internal exam sample papers. So again, we'll go through each question one at a time. You'll have opportunity to answer the question by pressing pause, and then one by one I'll go through my worked sample answers for them. Alright, starting with question 1, simple familiar. You're given a least squares regression line fitted to a set of data points described by the equation sales equals 52.3 times month plus 102 and an associated coefficient of determination value of 89%. Your job is to identify the explanatory and response variables, tell me the trend you're seeing in the data, determine the correlation coefficient, use the equation to predict the number of sales at 34 months, and use the equation to predict the number of months when there were 1,503 sales. Press pause and have a go. Okay, let's see how you went. So for part A, from the equation itself, you should be able to identify the subject of the equation, which is sales, is your response variable, and next to the slope value here, we have our explanatory variable. So explanatory variable, time in months, response variable, number of sales. Part B, describe the trend of the data. I can do this by referring to my slope. So this is my slope here. It has a value of positive 52.3 sales per month. So that indicates that there's a positive trend since it's going up in value from left to right. For part C, this is where I can use my coefficient of determination because I know that that's the R squared value. Okay, so if I simply convert that back to a decimal, I get 0.89. So then to find my correlation coefficient, I'll simply square root that value. So my correlation coefficient is 0.94. Moving on to part D, I'm going to use the equation to predict the number of sales at 34 months. So it's just a simple matter of substituting into the equation. So when months is 34, sub it in, evaluate it, and I get 1880.2 sales, which is approximately 1880 sales. I round that because I can't have 0.2 of a sale. It's discrete data, so I need to answer with a rounded whole sale number. For part E, use the equation to predict the number of months when there are 1,503 sales. So again, this is simple substitution. I'm just subbing in the sales value is 1,503 and I'm finding months. So again, I'm using my amazing solving equation skills. So I'll minus 102, divide by 52.3, and I end up with my months as 26.79, which is approximately 27 months. Let's move on to question 2. We've got a data table here showing us students attending university lectures in a week at UQ. You have to calculate the 3-point moving average centered around Thursday, the 5-point moving average centered around Wednesday, the 2-point moving average centered around Tuesday. Have a go and we'll check in. Alright, let's see how you went. So calculating a 3-point moving average around Thursday. There's Thursday, so there's my center. I want 3 points, so I've got to select Wednesday and Friday. and find the average of those values. So I add them up, divide it by the fact there's 3, and I have 413.3 as my 3-point moving average for Thursday. For a 5-point moving average centered around Wednesday, well, there's my center Wednesday. I need to select my 5 points of data, so 2 either side of Wednesday. So I'll average Monday, Tuesday, Wednesday, Thursday, Friday by adding them together and dividing it by 5, and I get 310. For part C, calculating a 2-point moving average centered around Tuesday. So there's my center Tuesday. Remember, with my even point moving averages, this is a bit more complicated because firstly I have to average Monday and Tuesday. So you can see that I've done 90 plus 220 on 2 and I get 155. Secondly, I have to average Tuesday and Wednesday. So that gives me 320. And then finally, I average those two values, which gives me my centered 2-point moving average around Tuesday of 237.5. Question 3, we're seeing here that there's a strong positive correlation between ice cream sales and sunglasses sold. You can see that in the graph below. It's fairly strong correlation because if I was to draw a line of best fit there, you can see that the data points would fit it quite closely. Your job is to explain why this scenario could be a causal relationship confounded by a third common variable, or alternatively just be coincidental. If you think about possible third confounding variable, I've said it could be temperature, because on hotter days people would buy things like ice cream and sunglasses. So if the temperature increases, ice cream sales increase. The temperature increases, sunglasses sold increases. So together you see that spurious relationship between the ice cream sales and sunglasses sold. And because of that reasoning, it wouldn't be coincidental. Question 4 is getting you to compose an equation of least squares regression line using some statistical values that you've been provided with, probably from a results table. Okay, so this is going to require you to use those formula on your formula sheet to find the slope and intercept values in that y equals bx plus a format. Just flicking over to your formula sheet so you can see where that is. Again, it's located on the second page, and here's the location of those two formula. All right, give it a go and we'll see how you went shortly. Okay, so using the formula from the formula sheet, I'm going to find slope first. So that's using my correlation coefficient and the sample of y, sample of x, standard deviations there. So I simply substitute those values in, negative 0.83 times 280 over 1.72, and that gives me a slope value of negative 135.12. I then need that slope value to help calculate my y-intercept, or a value. So I take the mean of my y minus the slope times the mean of the x. So if I pop those values in, that gives me a y-intercept value of 852.38. So then putting that all into the y equals bx plus a format for my least squares regression equation, I get a y equals negative 135.12 times x plus 852.38 as my least squares regression line. On to question 5. We have some seasonal rainfall volumes recorded from rain gauges across the Redlands, and we've got some results there over summer, autumn, winter and spring. You've also been provided with seasonal indices that were calculated using the rainfall data from 2015 to 2019. You have to calculate the missing seasonal index for winter, and you can see it's missing. And then you have to determine the seasonally adjusted rainfall for winter in 2019 to the nearest millimetre. So have a think about how you can approach these two questions and give them a go. Right, checking in. For part A, we need to remember that the sum of these seasonal indices will equal the number of seasons present within a cycle. So here we've got 4. So those seasonal indices should add up to give 4. So for A, just working backwards, subbing in what you know, and we need to find our winter. We end up with a winter seasonal indice of 0.54. For part B, determine the seasonally adjusted rainfall. That just translates to meaning you have to deseasonalize your winter data. So we know that we use our seasonal indice to do that. Because we've calculated that to be 0.54, I'm simply going to align those two, and to get my deseasonalized value, it'll be 201 divided by 0.54, which gives us an adjusted rainfall of 372.2 millimeters, rounded to 372 millimeters. Question 6, we have here a table showing the number of customers who utilize a white goods repair company over the period of 10 years, where T represents the number of years. From that raw data, I have to construct a time series plot and then describe the time series plot by identifying any features such as trends, fluctuations, seasonality, cycles, and/or outliers within the time series data. Let's see how you go, and we'll check in. Okay, so I've just put in a hand-drawn time series plot there. Make sure you label the axes, draw any plots with a line, give it a title, some sort of reasonable scale. For part B, if I look within the time series plot, in terms of trends, I would say that there could potentially be a slight negative trend, because if you look within the 2 cycles that look like they're present, so 1, 2, when you align their similar points, you can see that they're both decreasing. And as I mentioned, there's presence of 2 cycles. They're cycles because they're greater than 1 year. So if it was a season, that would be some sort of time frame that's a year or less, that has some sort of repeating up and down pattern. So you can see that a period length of the cycle is approximately around 5 years. Although we know that with cycles, they don't have to be the same exact period length every time. So just documenting that. Potential negative trend, cyclic fluctuations, one cycle is approximately 5 years, no seasonality, and no outliers. Question 7 looks like it's a bivariate data question, and you've been given data on number of hours studied by a sample of 10 students and the grade they earned in an exam out of 100 marks. You have to construct a scatter plot, describe the relationship in terms of strength, direction, and form. Using a calculator, determine the linear relationship for this data by fitting a least squares line to the data. Interpret appropriately the y-intercept and slope of the fitted line in the context of the data. determine the coefficient of determination and interpret this value in the context of the data. And finally, use your result from part C to interpolate the grade achieved by someone who studied for 3 hours. Give it your best go, and we'll check in with my sample answer shortly. There's my scatter plot. So labeled axes, appropriate scale, title, points plotted, hopefully fairly accurately. Part B, describe the relationship in terms of strength, direction, and form. Looking at the scatter plot, there appears to be a linear relationship there. It looks fairly strong. If I put in a trend line, those points would be quite well placed close to the trend line, and it's in a positive direction from left to right. Later on, when I calculate the correlation coefficient, that helps support that as well. Using your calculators in part C, determine the linear relationship. I got an A value of 44.94 and a B value of 13.47. We'll just quickly refresh those that have forgotten how to use their calculators. You click on Mode, Stat, and we want option 2, A plus BX, and then we'll go up and put in our data. Hours studied is X, so you simply just enter in, pressing equals, all those bits of data. Then go back up to the Y column and enter in the associated Y values. Quickly go through and check that all your data entry is correct. Press your AC button. So then to access the statistical functions on the calculator, I press Shift 1. Option 5 for linear regression. We'll need A and B and R. So A is our y-intercept. So select 1 equals 44.94. We want our B values, option 2, 13.47, giving us our equation y equals 13.47x plus 44.94. If I put that in terms of the data, I've got your grade is equal to 13.47 times the number of hours you studied plus 44.94. Moving on to part D, interpreting your y-intercept. Well, that would be the grade you earn with 0 hours of study, so no study. So you'd receive approximately 45 marks out of 100 because this is our y-intercept value here. For your slope, that's our value next to the x variable. So slope tells us that the grade will increase by approximately 13.5 marks for every hour you've studied. For part E, we can go back to our calculator, access our stats functions underneath reg. Option 3 will give us our correlation coefficient, which is 0.9908. If I simply square that to get my coefficient of determination, I get 0.982-ish. So that coefficient of determination supports that a 98.2% variation of grades can be explained by the variation in the number of hours studied. Moving on to the last part F, we're going to use our result from part C to interpolate the grade achieved for someone who studied 3 hours. So if I know the grade is 13.47 times hours studied plus 44.94, I'm just going to sub in 3 hours, and that gives me a predicted grade of 85.35 marks, so around 85 marks. Question 8 is looking at a linear relationship between levels of carbon dioxide in the air and time in minutes, so time series question. The plant's been placed inside a closed container and we've got results showing the carbon dioxide levels as time progresses. You have to determine if the relationship between carbon dioxide and time is linear by constructing a residual plot. Then use statistical functions on your calculator to analyze the data to predict the value of carbon dioxide left in the closed container after 10 minutes has elapsed. Press pause and have a go. Time to check in. For part A, determine if the relationship between carbon dioxide and time is linear by constructing a residual plot. So that means we need to know our residuals. In order to do that, I have to first fit a trend line. So using my calculator, I can come up with a least squares regression line by entering in my data. So my carbon dioxide levels will be my Y values, time will be my X values, and that will pump out an A value of 781.4 and a B value or slope value of negative 56.5, giving me a least squares regression line of Y equals negative 56.5 times X plus 781.4. For those that need the calculator help, checking that with your calculator. Option 5, A, 781.4, good. B, negative 56.5. So that gives us our regression line. You then use that regression line to create your values for the trend line. So I want to know on the trend line at time 0, what would be the value on my trend line. So it would be 781.4. If time was 1 minute, I'd put in negative 56.5 times 1 minute plus my 781.4, and I get a trend line value of 724.9. I'll do that for the other ones. So for example, if I was doing 4 minutes, you could simply press the arrow keys on your calculator, change that number to 4, and you get 555.4. The residuals are then the difference between your actual carbon dioxide values and the least squares line carbon dioxide values. All you're doing is you're finding the difference between these two values. So you can see for time 0, the difference is positive 0.6. For example, time is 3 minutes. The difference between the trend line and the actual is negative 2.9. So they're the residual values you should have for that data. And use those residual values to create my residual plot. And if you look at those values, they look fairly randomly scattered across that center line. So that supports the linear trend. Also, if you check your correlation coefficient value, so we use our statistical functions again under option 5, and then we choose option 3R, we get a negative 0.9997. So that's a very strong negative trend there. Lastly, for part B, the question wanted us to find the carbon dioxide levels when time is 10 minutes. So simply using the model equation I've come up with, I'm just substituting in when time is 10 minutes, and when I evaluate that, I get 216.4 parts per million of carbon dioxide levels. Question 9, I've just shrunk down a little bit So apologies for the smaller writing, just so I can fit everything in. We've got some data from a popular hotel on the Gold Coast regarding seasonal occupancy of rooms. So you can see there in terms of seasons, we've got spring, summer, autumn, winter. Your job is to deseasonalize the time series data to remove any seasonal fluctuations. I want to see a plot of the raw data and deseasonalized data on a time series plot using Excel and comment on the trend you observe. Using a calculator, determine the least squares regression line of the deseasonalized time series data and interpret the slope. And finally, use the model to predict the room occupancy for summer in the 2019-2020 year. Okay, give it your best go and we'll check in with my sample response shortly. Okay, how did you go? In the table here, I've put my sample answers, and you'll notice this side here I've also done some example calculations. The first thing you need to do when you're deseasonalizing data is for each season you need to find the seasonal average. So if I take this first year, add up all of those values, divide it by 4, I get a yearly average of 1660.5. I then use that seasonal average to find the seasonal indices for each of these seasons. From there, I would divide each of these seasonal values by the seasonal average. So for spring, I would divide 1770 by 1660.5, and that would give me a seasonal index for spring for 1.07. If I moved on to, say, the third season, I would use this seasonal average, divide, for example, spring in that third season by 1600 divided by 1519.75 would give me a spring seasonal indice of 1.05. From there, I need to come up with an average seasonal index. For example, for spring, I would choose the spring indices for each of those 3 seasons, and I would average them, so add them together, divided by 3, and I get a spring seasonal indice of 1.05. And I'd do that for the rest of the seasons. Finally, to end up with my deseasonalized data, so say we look at winter. If I do winter of season 2, let's deseasonalize winter of season 2. I would then go and use the winter average seasonal indice, and I would divide the 1341 by my 0.82, and that would give me a deseasonalized figure for winter of 2016-17 season of 1635. You need to make sure that you round these deseasonalized values to the nearest whole room occupied, because you can't have part rooms being occupied. So that should be your finalized table values for part A. For part B, plotting the raw data and deseasonalized data on a time series plot using Excel. My Excel graph looks like this. It appears to be a negative trend. If you look at the smoothed out deseasonalized line there. So unfortunately for the hotel, it means that there's less people occupying rooms over time. For part C, we need to use a calculator to determine the least squares regression line of deseasonalized time series data and interpret the slope. Okay, so when you enter in these values in your calculator, you need to be careful how you enter in your X values. So if you look at the number of seasons that's passed, you should have a total of 12 seasons. So that will be your X values. Your Y values will be your deseasonalized data. Once you've entered in that data, quickly check through that you've entered it in correctly. And we are after the A and B values for our regression line. So 5, y-intercept value is 1697.74. Our slope value minus 15.45-ish. So that gives us a regression line of y equals negative 15.45x plus 1697.74. We put that in the context of the data. That means our occupancy can be predicted by minus 15.45 times the number of seasons after we started plus 1697.74. And our slope is indicating a decrease of approximately 16 rooms per season as we go along. For part D, it wants us to predict the occupancy in summer of 2019-20. So if I consider where that is in terms of the timeline, I've got the 12 existing seasons plus 4 seasons of the 2018-19 year plus 2 into the 2019-20. So altogether, that's 18 seasons after we've started. I then pop that into our deseasonalized regression model to give us an occupancy of 1419.64. And then lastly, I can't forget to re-seasonalize the data using your summer seasonal indice of 1.15. So then that gives us an occupancy of 1632.586. Again, I need to round that to a whole number room. So rounding it up to 1633 predicted room occupancy in summer of 2019-20. Okay, that was pretty full on. Moving on to question 10. We have monthly figures for a clothing company, and the CEO suspects the company is in trouble and sales are slowly decreasing over time. And he stated that if the trend is negative, the critical deseasonalized average number of sales is 600 per month. So here's our raw data. You have to develop a least squares regression line to investigate and model the long-term trends in the time series data after deseasonalizing, and use the model to determine if and when the company could be in trouble, and use Excel to support your response. Okay, so it's a complex unfamiliar question. You've got to think about the steps you can take to come up with a conclusion. So have a go, and we'll check in very shortly. Okay, so working through the question, my first step would be to construct a time series plot, simply because I suspect there's seasonal activity there, and I want to see how long the seasons are. So when I plot it on a time series plot, you can see there there's 2 obvious seasons within a year. The seasons appear to be 6 months in length each. From there, to make further predictions, I'm going to have to use a least squares regression line. So I'm going to have to deseasonalize my data. So going through the process of deseasonalizing the data, we want the average sales per season for this first season, and I get 840. Second season, 796.5. From there, I work out the seasonal indices for each month within both seasons. I then work out the average seasonal indice for the parts. So January and July are the first part of the season, so I average their seasonal indices. February matches up with August, March with September, April with October, May with November, and June with December. So then deseasonalizing that data, I use the seasonal indices that I've found, and I go through and divide each of those by that seasonal indice. Okay, that gives me deseasonalized data that I've roughly written out here. Be much better organized into a table, but this will do. You can see I've organized that information a little bit more nicely into an Excel table. I then created my time series plot for the raw and deseasonalized data. Okay, last part, I would create my least squares regression line by putting in my Y values as the deseasonalized data. X values I would enter in as my number of months that have passed by. And when I spit out those values from my calculator, I get a y-intercept of 852.5, a slope value of minus 5.27. So the equation I come up with is minus 5.27 times x plus 852.5. Putting it in the context of the data, the deseasonalized sales are going to be minus 527 times the number of months that's passed plus 852.5. And the slope showing a decrease of just over 5 sales per month. So the company is definitely in trouble. Last step, to check when average deseasonalized sales are 600 on the regression line. If I sub in that sales is $600, I need to know the number of months that's passed. So working through that using my amazing solving equation skills, I get 47.9 months have passed when I get to 600 sales, deseasonalized sales. So approximately 48 months is around 4 years when your sales will hit that critical level of 600. How did you go with those questions in general? Hopefully pretty good. If not, be a good idea to identify what content areas you still need to work on. Definitely go over those content areas. I hope this has helped give you a good picture on how you're going with analysis of time series and bivariate data. Thanks, Year 12s.